Greetings, mathematicians. In this video, we're going to continue our work with our exponent properties. Specifically here, we're looking at the quotient rule, and you can see here that the quotient rule says that if we have the quotient, or a fraction, or the division of two exponents where the bases are the same, so their x's here again, or you can see in the examples, for example, this middle one, they're both 3's. So they don't necessarily have to be x's, but the bases have to be the same. We're going to keep the same base, and we will subtract the exponents. So we'll do similar to what we did previously, where we'll look at the one here in the middle with the numbers, and we'll kind of see why this rule works. And then after that, we'll use the rule to kind of end up showing less work moving forward. So we'll use kind of just the definition of an exponent first on this middle problem. So we'll start with the 3 cubed in the numerator and rewrite that as 3 times 3 times 3, and the 3 to the 8th in the denominator. And what's going to happen here is, remember that if you have something that is the same in the numerator and the denominator, that essentially what's going to happen is that these things end up dividing out to 1. 3 divided by 3 is 1. And what you end up having left is you have a couple that don't divide out to 1. Specifically, you have 5 of them left over. And if you pay attention to where they are, there's 5 of them left over in the denominator. And there's nothing left over here, so there's really just this factor of 1. Now, we haven't really talked about negative exponents yet, and we kind of said that we'll address that shortly. When you have a negative exponent, that's similar to having it in the denominator. So we'll address this a little bit more clearly in the next step, but this is the same thing as this. Probably it's more correct to write it this way, having it in the denominator. We usually don't like to have negative exponents, but that's what's going on here. These are equivalent. So, kind of the quote-unquote shortcut is that we could have just done the 3 minus the 8 and gotten the negative 5. We're seeing what the difference between those are, and that's telling us how many extra factors of 3 there are. So let's go back to the first problem, the one with the x's. So, again, if we kind of did this the long way, we would divide out the common factors, and we would see that there are 3 x's left in the numerator. And then that gives us an x cubed left over here, and nothing in the denominator, which is like a factor of 1, so that's just x cubed. Or, using our new shortcut, our new quotient rule, you could have just said 5 minus 2 is 3, so x cubed. Okay, so on the last one, we'll just use the rules only. So first thing I would do here is kind of like we did in the last one where we had multiple sets of variables, is I would try to rewrite this. First thing I see going on here is that in the denominator, I have more than one factor of b. So I'm going to leave the numerator alone for the moment. And in the denominator, I'm going to go back and review my product rule and take my b to the first and my b squared and rewrite that as b cubed, using that product rule where I keep the same base and I add the exponents. And then from there, I've kind of got 2 problems going on here. Remember that I don't have to necessarily rewrite this, but this is the same thing as this. So I can kind of almost split it up as to just the a's and just the b's, and then use my quotient rule twice. So I've got a cubed over a to the 4th. I can either think about what I did in the previous two problems where I'm kind of crossing off the things that are going to divide out to 1. And if you think about that, I'm going to end up having 3 A's in the numerator and 4 A's in the denominator. And if I cross those off, I'm going to end up with 1 A left over in the denominator. And for the B's, I'm going to have 5 B's in the top. I'm going to have 3 B's in the bottom. I'm going to cross those off. I'm going to end up with 2 B's left over in the top. So I'm going to end up with B squared over A. Now that's the same thing as A to the negative 1 B squared. Again, this is probably the better answer because we don't usually like to have the negative exponents. All right, next up here is the set of problems for you to try on your own. Go ahead and see if you can use the quotient rule. So keep the same base, subtract the exponents, and see what you come up with. Pause the video while you do that, and then come back to check your work. All right, so now that you've had a chance to try these, let's see what you've come up with. Again, for the first one, coming up with x to the negative 4th, we're going to talk a little bit more about what to do with these negative exponents. So if that's what you have for now, that's okay, but we're going to deal with that negative exponent shortly. For the second one, keep the same base, so keep the 6, and then subtract the exponent, so 5 minus 3 is 2. Either of these is acceptable. You can leave your answer 6 squared, or you can change it into a 36. For the j's, negative 3 minus negative 4 is 1, so j to the first is just j. For the last one, kind of split it up into two mini problems. Work with the 7's first. 5 minus negative 3 is 8, so we have 7 to the 8th. And then work with the y's next, so negative 6 minus 4 is negative 10. Again, we're going to learn how to deal with that negative 10 shortly, so we would like to simplify this further in the next section to get rid of that negative in the exponent, but for now that's okay. And the 7 to the 8th, that works out to be a pretty large number. If you really wanted to simplify that further, I think it's 5, 7, 6, 4, 8, 0, 1, but there's really no reason that you have to work with such large numbers. That's one of the benefits of using exponents. So I'd probably just leave that as 7 to the 8th. We'll go ahead and make that our last set of problems in this video, and then we'll do another exponent rule in the next video. So goodbye for now.